Howdy, Chem friends. Welcome back. My name is Ari,
And my name's Jeremy.
and this is our presentation on the attributes of emission intensity. In terms of emission spectroscopy, emission intensity is the relative or proportional amount of photons of a certain wavelength emitted by a substance as measured by the spectrometer.
Emission intensity does depend on the properties of the fluorescent dye. This can be observed in the first experiment where the peaks of the green and red fluorescent dyes were shown to have different intensities. The reason that the red has a lower intensity than green is because red is comprised of larger molecules and thus has more electronic states because its molecule has more electrons, meaning that the electrons, once they are excited, have to transition through more states because they can reach their emission event, demonstrating that, on average, it takes longer for a red molecule to emit a photon than it takes for a green molecule to emit a photon. So therefore, green has a higher intensity than red because green emits more photons per unit of time. It should be noted that not all of these energy level transitions are of a high enough energy difference to produce a photon in the visible spectrum, and that energy is instead released as heat or vibrationally.
Emission intensity also depends on the properties of energy input, because depending on the type of energy input, molecules can be excited vibrationally, rotationally, or electronically, like how infrared radiation can excite molecules into vibrational states.
In order to understand this better, let's think of an atom as a college student. The properties of dye is analogous with said student's tolerance levels, and the type of alcohol is representative of the energy input. Every person has a unique tolerance level, just as every molecular compound, like dyes, are composed of different atoms with different energy states. For some, beers may not carry enough alcohol to excite the person or make them buzzed, just like certain energy inputs are not enough to excite the electron to a higher energy level. Vodka, however, may have enough alcohol concentration to intoxicate this college student. The emission of alcohol, also known as throw-up, is directly proportional to both the student's tolerance level and alcohol consumption, just as emission intensity is directly influenced by molecular composition, atomic composition, and form of energy input. Let it also be noted that the mixed sample having a peak in the red spectrum of higher intensity than the peak in the green spectrum is because, when the molecules are mixed, green dye molecules and red dye molecules both absorb energy from the activator and emit photons, but some of the photons emitted by the green dye are low enough energy to be absorbed by the red dye, and this lessens the green dye's intensity. The reason this doesn't happen vice versa is because the red dye's photons are too low in energy to be absorbed by the green dye molecules, as energy levels are quantized, except for some extreme cases that happens far too infrequently to have significant impact.